When we looked at 2D shapes, two of the properties that we had to find out about the shapes that we were looking at were the perimeter, that's the distance around the outside edge of the shape, and the area, that's the amount of space inside the shape. There are also similar properties that we have to look at for the 3D shapes that we need to know about, in particular the prisms. Now what we need to be able to find for 3D shapes is something called the volume, which is the amount of space inside a 3D shape. So it's kind of like area, but the 3D equivalent. Now we only need to be able to find the volume of prisms made from shapes that we have to be able to find the area of. If we can find the area of it, then we can find the volume of a prism made from it. Because that's kind of how we can define volume. It's kind of how we can talk about it. Think about, for example, a cuboid and how we might make that cuboid. Here is a flat two-dimensional rectangle. Now this flat two-dimensional rectangle has an area of some sort. And we could calculate that if we knew how wide it was in one direction and we knew how tall it was in the other direction. We could multiply those together and find the area of this rectangle. Now what I could then do is I could take another copy of this rectangle. If it's another copy, it will have the same area. I could take another copy of this rectangle and I could place it on top or behind. And then I could take another copy of the same area and I could place it there again. And I could take another copy and I could place it behind. And another copy and I could place it behind. And another copy and I can place it behind. And I can keep taking copies of this rectangle with the same area each time. And I can build them up. And I can make, well, that's a cuboid now. And all of those areas have joined together to give us a cuboid. And the volume is clearly going to be linked with the areas because it's just multiple copies of the same area. So in fact what we need to do for volume is we need to find, first of all, the area of this shape, the shape that makes up the prism. And then we need to just have as many copies of that area as we need to stretch that shape back into 3D space, to pull it back, to make it into a 3D shape. That's all these copies. Let's have a look at that with an example, because it's slightly easier to explain with the numbers. Work out the volume of the cuboid. So, what we're going to do, and we're going to always tackle these volume questions in the same way. First thing we're going to do is we're going to notice which shape it is that makes up the prism. And the face that is flat on the page and has been stretched into a prism is that rectangle at the front shaded in orange. And I'm going to make a quick sketch of that rectangle. And this is my step one. I'm going to fill in the dimensions of that rectangle. So it's 5 across the bottom, 5 centimetres, and in height, well, the height isn't listed here, but it's the same as the height over here, so it must be 2 centimetres in height. That rectangle has an area, and the area of that rectangle, well, we calculate the area of the rectangle by having this across dimension and this up-down dimension, and we times them together. So the area is 5 times 2 is 10 centimetres squared, and I am going to put the units on here. What then happens to make this into a 3D shape is we've taken that area and we've got 7 centimetres worth of copies of that shape layered up to make it into a 3D shape. So we've taken that 10 centimetre squared area and we've stretched it, we've pulled it back into 3D space, 7 centimetres worth. So then step 2, our volume can be, well, we've got this area of 10 centimetres squared and we've got 7 centimetres worth of it. So we've got 7 centimetres, lots of the 10 centimetre squared area. I.e. we've got 10 times 7 is 70 for the volume. And we have a volume of 70. But 70 what? Well, we need a unit. Well, we've got centimetres squared times another centimetres. So our units are going to be centimetres squared times centimetres will be centimetres cubed. Alternatively, there are 1, 2, 3 dimensions, 3 different ways of measuring that we have used in this question. 70 centimetres cubed with the 3 dimensions there and the cubed matching up. Units for volume will always be units cubed, so that's metres cubed, centimetres cubed, and so on. I will point out at this point that the volume is not as simple as take the 3 different numbers, times them together, as we'll see in this next example. Work out the volume of the triangular prism. So just like in the previous question, our first step, we're going to identify the face, the shape that has been stretched into 3D space to make the prism. And the shape that has been stretched into 3D space to make the prism is that triangle. I'm going to make a quick sketch of that triangle down here. And this is going to be my step 1. My step 1, I'm going to fill in the dimensions of the triangle. How far across the bottom? Well, 3 centimetres. And vertical height we've also got marked is 4 centimetres. That's from base to tip, 4 centimetres. I can now work out the area of the triangle. But then how do we work out the area of a triangle? Well, to work out the area of a triangle, we first have to turn it into a rectangle. And yes, we do need to do this because we need to work out the area of this front face when we're doing volume calculations, however we normally would for that shape. So the area of the rectangle will be (3 by 4) is 12 centimetres squared. But we weren't interested in the rectangle, we were interested in the triangle. And to find the area of a triangle, we turn it into a rectangle, we work out the area of that rectangle, and then we halve that to find the area of the triangle. 12 divided by 2 is 6 centimetres squared for the area of the triangle. My second step then is to take that area of the front face of 6 centimetres squared, worked out by working out the area as we normally would for that shape. We don't abandon the rules just because this is a slightly different thing. We are still working out the area of that shape in the way that we would expect to. What I'm now going to do though, to finish this question, I can now work out the volume. I'm going to take that area of 6 centimetres squared and I'm going to pull it back into 3D space. I'm going to pull it back by 10 centimetres worth. So I'm going to have 10 centimetre lots of the 6 centimetre squared. That's the layering to make it into a 3D shape. 6 by 10 is 60, and my units are going to be units cubed, so 60 centimetres cubed. Which you will notice is not the same as 3 times 4 times 10. So volume is not as simple as just timesing the numbers together. We have to, step 1, work out the area of the front face, however we normally would for that shape. Whatever shape it happens to be. And it could be any of the shapes that we've looked at, finding the area for. And then step 2, we have to stretch that area back into 3D space, i.e. times that area by how far back the shape has been stretched. And that will work for finding the volume of any prism.